Welcome back to our channel, ladies and gentlemen. How do we determine the red area of this radical geometry problem? So if we transfer this into the whiteboard, how do we determine the red area given this to be a parallelogram? So for you to get the area of a parallelogram, it is the height times the base. So if we drop the perpendicular height in that manner, we can label that is point X and that is point Y, and that is a perpendicular height, so that the height of this smaller triangle, if you let that is to be point E, the height of this smaller triangle to be H1 and the height of this bigger triangle to be H2. So if you let that to be H1 and this to be H2, then what does it implies? The height of the whole parallelogram you let to be H. So that will implies that H, the height of the whole parallelogram, is H1 plus H2. Now, if we use the scale factor, then you start with the linear scale factor. The linear scale factor to be H1 over H2. So that when you now get the area scale factor, you square the linear scale factor. That is H1 over H2 squared. And that area scale factor, we've been given the area to be 2 for the smaller one and 18 for the larger one. So you've compared the area scale factor. So for you to get H1 over H2, then you look for the square root on both sides. So square goes with square root to remain with H1 over H2 to be equals to square root of 2 over 18. 2 over 18 is like 1 over 9. So square root of 1 over 9 is 1 over 3. It's 1 over 3. So from there you can now see when you multiply both sides by H2, when you multiply both sides by H2 goes with H2, you remain with H1 is a third H2. So you found H1 is a third H2, and remember what was H? H was H1 plus H2. So it means H is H1, but H1 is a third H2, then it is plus H2. So a third H2 plus 1 H2, you get 4 over 3 H2. So we found that the height of the parallelogram H is 4 over 3 H2. Now, if you let the base of this parallelogram from D to C to be A, so if you let that length DC to be equals to A, then the area of the parallelogram ABCD, the area of the parallelogram ABCD is base times height, because the height of the parallelogram is H. This is the area of the parallelogram ABCD. So how do we determine this area of the parallelogram? We will start with this smaller triangle, this smaller orange triangle, triangle CDE. So if you take this triangle CDE, what is the area of this triangle CDE? It is a half base, which is A, times its height, which is H2. And the half base times height H2 is giving you an area of 18. So it means a half A times H2 is equals to 18. And what is H2? Remember, H is 4 over 3 H2. So this implies that H2 is 3 over 4 H, if you make H2 the subject for the formula. So we have a half A H2, where there is H2, you put the value of H2, which is 3 over 4 H, to be equals to 18. So what do we have here? A half times 3 over 4 is 3 over 8, then A times H is AH, to be equals to 18. Now you multiply both sides by 8 over 3. When you multiply both sides by 8 over 3 times 8 over 3, this side, that will cancel out. You'll remain with AH to be equals to 3 goes here once, 3 goes here 6. 6 times 8 is 48. And what is AH? AH is the area of the parallelogram ABCD. You can see the area of the parallelogram ABCD is AH, meaning this is the area of the parallelogram ABCD. So what is the red area? So the red area is the area of the whole parallelogram, which we found to be 48. Then minus the sum of the three areas, 18 plus 2 plus 11. 18 plus 2 plus 11. Then you get the red area to be 17, and our units here is meter square. Ladies and gentlemen, that is the simplest means to determine the red area of this radical geometry problem. Thank you for watching, and see you again in our next presentation.